Okay, good day to everybody. I would like to welcome everybody joining here physically and on the webinar. Today I'm very excited because we are starting a brand new series of webinars on engineering education. The main idea is that we use the opportunity to invite worldwide renowned practitioners in introducing new practices, new methods in teaching engineering, a broad spectrum of engineering, and to discuss how applicable this is to our individual local communities. So basically, webinars are intended to people who teach engineering at a higher education level, regardless of the specific engineering profession. But I guess that most of the things will be interesting also to people outside of engineering education. Webinars will be recorded and available on YouTube. Today we have our first webinar on the topic of team-based learning, and I'm happy that I could invite Vesna Najdanović from Lancaster University, who is teaching chemistry. And from my personal discussions with her, I learned quite a bit about team-based learning and try to implement it with relative success in whatever I do with my students. So Vesna, thank you for being with us. Thank you for accepting this invitation, and please use next 20-30 minutes to try to bring us closer to understanding what can be done with team-based learning, what can't, and how do you implement this? What is your experience?
Okay, so good morning. Thank you very much for inviting me, and it's a pleasure to open your session of webinars on such a diverse methods of teaching, which I'm also interested to follow up with other speakers after me. So my name is Vesna, and I work at Lancaster University at engineering department. In engineering department, I'm a lecturer of chemical engineering. So just a little bit to introduce. So our department is a general engineering department. So students that come here have all the same subjects during their first year, and then in the second year they have their specific subjects to then learn. So in a year one they are quite exposed to different kind of subjects. So they are having a mix of mechanical engineering, electrotechnics, electronics, and as well as chemical engineering. So it's quite challenging actually to teach that first year and bring them all at the same level. So what I did, I have implemented this team-based learning, which is in the large kind of large lecture room, so a lot of students, and I will now share a little bit of how it works and what are my experience. So I think the best way is just to probably to just be a little bit informal, so you can probably, I don't know how do you organize this, but you can just stop me and ask questions wherever you want. I'm happy to do that as well. So starting now, let me see, okay, it is. So the motivation, I think we all know that, just to hear someone is it's not really enough to transfer knowledge and to really learn. So there is that famous proverb which says, what I hear, I forget. But then what I hear and see, I remember a little bit. And then what I hear, see, and ask questions and discuss with someone else, I began to understand a little bit. And then what I hear, see, discuss, and do, I acquire actually knowledge. But actually what I really master is when I teach. And I think as a lecturers and in education profession, I think we experience this a lot. I think most of us would really agree that actually when you started to teach to another students and to start to translate those difficult concepts into something as simple as possible, it's really when you start to understand the subject. So that's all nice, and it's all very useful to know, but it's very difficult to actually implement in this kind of environment when we have, more than 100 students, 150, sometimes even more. So it's really difficult to foster that active learning and to have students to see, to do, to hear, and to discuss with others, and even less to teach each other. So I have, when I was given to design was a new module, I've decided to do a little bit different. So I went into team-based learning and read a lot about it. So what is the team-based learning? So it is a kind of similar teamwork as a problem-based learning, which is much more popular and people know. But this team-based learning is something that you can scale up to a small level and to the very, very big levels. So I do typically in a lecture theater with more than 100 students. So that's the main advantage of this method. So it has a few elements. So first of all, there are permanent teams that are formed. So they are formed by me, and we will talk about it later, why it's important. So it's important to have diverse team of 5 to 7, 8 students, whatever is the situation. And then we start with the preparation phase. And preparation phase and preparation phase can include something like giving lecture, or just giving them some material over internet so that they can prepare. So I use Moodle, I put notes on Moodle, I put examples on Moodle, and then I give one lecture on that subject. So when we finish all this, first thing that actually they do is this individual readiness assurance test. So this is a first test that is done online out of class, and its role is actually to test whether students are prepared for what is coming. So to test their basic knowledge. What is important, I will talk a little bit later about it, to follow the Bloom's taxonomy. So this shouldn't be very difficult questions. It should be lower levels of Bloom's taxonomy, really. And so when they finish, this is out of class online, they come back, and then they do this team readiness assurance test. So it's a very similar test as individual, but so I just change actually numbers in there. So it generates, so they do it in class, in their teams. They submit one test per team. So this allows them to have a discussion between each other and to decide, which answer to select. So with all this, I have a lot of information now when we finish all this, because I have online tests, their results. I also have this team test. And with all this, I now have a lot of idea of what is bothering them a lot. So what is not clear for them. So that gives me opportunity next time when I come to explain specific questions. So to give them feedback, so they get a feedback through having these results of individual and assurance test and readiness assurance test, and also to clarify those troublesome questions, and then to give a mini lecture on that. So when we finish all these, so the next few sessions of the same unit, we actually spend in this team application exercise. And this is something that is now higher, it covers higher Bloom's taxonomy levels. And it's, let's say, exam-like questions. So where students work in their team, so I project a problem. It's usually the multiple choice questions, so they can select their answers into their teams, and then for each of them we get an answer. So so what is important is that this team-based learning is nothing I have invented. It was invented in, wait a second. I don't know why you should see this. anyway, I cannot show you, but so what I did, it's a number of publication per country, and what can be seen that most of the papers that were published about this team-based learning come from USA, so it's not surprising because it was invented there by business and management people actually at university who started to practice this kind of learning method. And it's also interesting to see that, you know, educational research, especially health and life sciences, I think are on the frontier of all these innovative methods. And I guess that these are disciplines which realize from very beginning that these skills of working together in team is absolutely crucial. So there comes pharmacy, nursing, and engineering is really, really very, very low. And computer sciences, which is probably also relevant to your faculty, is really low. So it seems that the health and life sciences people are somehow more interested into this sort of innovative learning. But it's not surprising. I think it's also in other teaching methods we can see in literature. So how did I do at Lancaster University? I was given this first year module, which is a subject called Process Engineering Fundamentals. It's 8 credits, so it's a short, it's compulsory for all students, so chemical, nuclear, mechanical, electrical, and electronics engineering. And as you can imagine, it's a bit challenging because UK system is made in such a way that I could have, let's say, people from, so students who didn't have chemistry for the last 2 years. So it's quite difficult to bring them all together. So it's usually, I have 2 lectures of 1 hour per week, and we have also, each student have 2 to 3 hours practical section per each week, and it lasts for 10 weeks like that. So I usually, what I do, I split them into teams. So these are permanent teams. So it's what I do before they come. And this allows me to actually have quite diverse teams. So what I do, I put in one team to have, let's say, students from different courses. So from chemical, from nuclear to mechanical, electrical, electronics together. Also students from B-Eng, M-Eng courses as well. And I also try to have a mix of international with national students, but also, which is quite difficult probably, I don't know how it's in your faculty, to have some females there, males and females, so it's, but it's challenging because we don't have that many. So I usually have 24 teams, for example, last year, this year I'm having only 100 students, so I managed to put 15 at the same time. So we split them because we have too many students, so we have a double teaching this year. So the whole module is, as I said, divided into 3 different units, for example. So you can divide into units which are logical parts of your module. So in my case, we are first covering process variables. So they have a little bit of recap of, you know, what are the units of temperature, pressure, volume, etc., how to convert them, but also more how to convert more complex units like heat capacity, universal gas constant, and things like that. Then we pass to mass balances, and we do mass balances for systems with or without chemical reaction, and then we are moved to single and multiple phase systems. It really doesn't matter. So, but any module could be divided into few units which should be covered. So, and as I said, teams in team-based learning. So it's one instructor simultaneously facilitates many small teams in a large classroom. So it's not like problem based learning. So I am all alone on myself in a lecture theater, which is really important for for faculty and resources that are needed for this. So teams need to be large enough, so 5 to 7 members, and it's sometimes I get feedback from students they would prefer to work in a teams of 2-3 people. But it's really not possible. It's important that we have a lot of students in the one team because to guarantee there is sufficient intellectual resources to solve the problem. But not only that, but for example, there might be a session that half of the group does not appear if they're just, had a party night before, so they didn't bother to turn up. So in that case, you're still ending with 3-4 people, which is quite sufficient for problems to be solved. So what is really important is that teams are created by instructor. So it's, as I said, it's important to guarantee these balanced and diverse teams with wide range of skills. So you don't want to have teams of very weak students and then opposite teams with very strong students. So you want to have a mixture of all of those. Teams are also permanent, so they start from the first session and then end up with the second to the end. So they work in their same teams all the time. So now coming back to this preparation. So as I say, this is optional. I usually like to give one traditional lecture where I introduce the unit. So I start to talk about mass balances, how to perform them. But I also have additional material, which like notes I prepare for them and then put on Moodle, or you can use whatever platform for that. But this, what is important, this individual preparatory reading can be actually anything. You can give a chapter in a book if you have a good textbook which follow what you're covering. That's absolutely fine, and this allows students to have as many examples, for example, and as many explanations as possible. So that is a preparation. So when we finish this preparation, then we go to this readiness assurance process, which consists of 2 tests, as I said, online and in class. So this is, the first one is individual readiness assurance test. So it's a multiple choice question, which I organize online. So I usually open them. I usually open them on Friday, and then they're open on until the end of until midnight on Sunday or something like that, and students can get there whenever they want, but they need to then finish it within 1 hour or so. So you can put that, and then we do the same very similar test in their teams when they come back to the first session. So the aim is to actually motivate students for their preparation, because you can go there and tell them, go and read this before the next lecture, but it will not work if you don't have something to motivate. And in my experience, the only way to motivate them is to give them a mark or something. So it's really important to motivate their preparation and to be sure that they will actually do something when you ask them to read that chapter. So it's also so as I said, there are usually multiple choice questions, which is easier to mark, and also allows me to have a lot of calculated questions I do it through Moodle. I'm using Moodle, but I think all other platforms can be useful for that. So main concepts are tested here. So that's important because, sometimes as a lecturers, we want to ask those hard questions, and we should, keep in mind they did this on their own. They had just one lecture and they read a chapter in the book. So we should really test those main points if they, you know, make concept, if they understood something. So it's to test their knowledge, comprehension, and application, direct application, rather than analysis, etc. So it's really important to keep that relatively easy test, I would say. And then during team tests, so they are doing very similar tests. As I said, I just changed their numbers. So when they come, so from Friday to Saturday, this individual test is open online. They come next week, first session, we do team tests. And during that team test, they have really opportunity to discuss with each other how to solve the problem and to come to a consensus of their answers. So it's really important that they discuss, and so I try to really remind them several times during those team exercises that, you know, they shouldn't finish this team test without being sure that everyone knows how to solve problems. So when we finish this readiness assurance process, then we go to this feedback and mini lecture qualifications. So I take all these results with me. I know exactly what is bothering them, and then I can, next time, I can actually say, okay, most of you did this mistake in question number 3. Let's go through it step by step and we can solve. And while I'm doing that, I also call their attention to, you know, details like be careful with this, be careful when you do this. These are usually students' mistakes, so it allows me to really, you know, go into those details without covering really everything that is there. So when we finish this, we then go to exam-like questions. So these exam-like questions are in teams. So students work in their teams on progressively more difficult questions. So we are talking about higher levels of learning. So we are testing their ability to analyze, to evaluate. Well, create, it's a little bit difficult in this context of big classrooms, but I would say analyze and evaluate. It's really a good to spot. So these are exam-like questions, more difficult ones. So what is important to how to prepare them is to have the significant problems. So it's important that they have to, you know, put an effort for 5, 10, 15 minutes, depends on the problem, and to be solved. So it cannot be something very easy. It has to be the same problem for all teams, so all teams solve the problem. Sorry, they have to come to the specific choice of their questions. So again, it's a multiple choice question, and they have to simultaneous report. So how I do, I have a real-time quiz, again through Moodle. So I project a question and a few 5 or 6 options for answering. And I allow them 5, 10, 15 minutes, depends on a question. So teams work together, and when they're ready to submit their answers, then I open the real quiz, and then they can select simultaneously actually their answers. So, and then I can project and put again questions and show how different teams responded different, and then we can go step by step into problem how to solve. So the idea is through, rather than being there and just lecturing, just guiding them through this process of solving problems and going step by step. And then, you know, I also look to those multiple choice questions to design them in such a way that there is one certain answer, but other answers also correspond. If they made this mistake, or if they make this mistake, they would end up with something else. If they end, you know, so I exactly know how to explain. I said, probably you got this answer because you didn't convert units, or because you forgot about counting into material balance that there is a chemical reaction, or whatever was the problem to solve. So it really allows me then to go into details. So when I finish one, so we do usually in 50 minutes. It's a section, so it's a session, usual session time. I can do 3 or 4 questions, let's say 3 or 4 problems to solve. But it doesn't have to be 3 or 4. It depends on what it is. I think on later years, probably you can even spend 50 minutes of solving one single problem if it's more complex. So that's all individual, and it's all okay. Okay, so what is important is this peer assessment. So because the problem, as always with group works, is that there are team members that did a lot, there are team members that was not that much engaged into activities, there were people that are interested into subjects, ones that didn't even bother to appear, like to sleep or whatever, have other dynamics going on in their life, and that's all fine. But what is important is that score which they collected by doing all these team activities is actually adjusted to each team member by their peer evaluation. So the idea is to hold team members accountable to their teams, so they know this from very beginning. The other member of teams will actually evaluate their performance at the end. There is also lessens the likelihood of social loafing, probably avoids potential free riders, so people that are just not engaged, and might enhance motivation and ability to work together actually efficiently. And it's also important, I start, when I introduced, I start actually with explaining how important is to have these team skills and refer to that as this go by. So just to conclude, I think that this system allows us really to go through these different activities. So there is a kind of lecture, there is a reading material there is a audio and visual, so I give them demonstrations of how to solve the problems. There is a discussion that they have a lot into these classrooms when they come. They practice doing, and what is really, really important, they hopefully teach each other. So I would say that there are some disadvantages, and I guess it will come through your questions as we continue. But it allows, students that are engaged and students that really like to embrace this learning. I think it's quite beneficial. And really, my role there as someone on the stage a little bit changes. I'm just their guide. I guide them through problems and then point out a specific feedback. So it really changes a lot of dynamics. So classes are a little bit noisy. It's sometimes difficult to take over them, but it's all fine. I don't mind that. So I would say for whom it's not this kind of teaching is probably for those lecturers that are quite theatrical, those ones that are really very special, but I think they're just 1% of us are like that. So ones that really can keep attention of students for a longer time, I think it's pity for them, but for all us rest, which are normal lecturers, it's normal people, it really gives more activity, and I hope fosters a little bit of that active learning in this way. So I put here the resources to be used. So there is a team-based learning collaborative. So it's a community of people, of educators from around the world who encourage and support the use of team-based learning at all levels. So there is, I think Predrag asked me about some that you're engaged with the teachers in high school. So I think there are some examples of using team-based learning in high school level as well. So it's interesting to go. There are a lot of resources there. And there is also European team-based learning community which you can engage. So just to just notice that most of these people and their expertise is in health and pharmacy, nursing, medicine, is health sciences are, as I say, these are people that are that seem as mostly interested into this. Although we are engineers, we should be innovators, but it doesn't look to me as a very promising as a profession that likes to take new teaching methods. So maybe it's a good challenge and good opportunity to really embrace those things. And when I was starting, I bought this book, and I think it has all really relevant information. It's really easy to read. It's a nice book to read. So if you're interested, maybe have a look there as well. So with that, I would like to finish. Hello?
I would like to invite all our online participants to ask questions. You can use the chat box in Adobe Connect. And before we get these questions, could you, Vesna, go back to your slide where the overall process is described, and just give us an idea about time? How much time? I didn't get it quite. How much time do you need for each of the phases?
So and let's say, yeah, in a typical module, I would. Okay.
It is slide number 4.
Yeah, this one. So I give one or two lectures per unit. So that is, it depends of the unit. For example, process variables is quite easy for them. So I give just one. For mass balances, I give 2. And for the third, I give 2. So that's all I give as a traditional lecture. So then they do this online. So what I do, we also have so-called surgeries. So it's so I give, imagine I give so I have 2 lectures per week. First lecture is a normal traditional lecture, and then second I give a surgery, which means they can come and ask questions. So then there is this test, this individual readiness assurance test, which they do online on their own during weekend. So when they come, the first session, when they come back, is this team test. And then we spend with the team application exercises, like 2 to 3 sessions per unit.
What is the length of a session?
50 minutes.
50?
50, yes.
Okay, so you give lecture, then they read at home, then they do their individual readiness assurance test at home, and then they come to class, and then they have for team readiness they have 50 minutes.
Exactly.
Okay. And then for the explanation phase, how much time do you need?
So I do this here and there, you know, I don't do explanations and I don't spend the whole session, but I give them first to solve the problem, for example, in Teams, this team application exercise. When they select the problem, then I go into details how to solve that problem and where did they make mistakes. That's where I stop and say, and don't forget this and don't forget that. And as you've seen in notes, this or that, you see. So
this team application exercise is how long?
So in, as I said, so I would, three, let's say typically 3 sessions of 50 minutes.
Aha, okay.
So in one session, I cover, for example, 3 or 4 questions to answer in that 50-minute session.
Questions? Questions here?
Maybe I can ask. Okay, can you hear me? Okay,
Yes.
here's the microphone. My question relates to this peer evaluation. When you have these team members and when they have to evaluate each other, how do you ensure that this is objective? So how can you ensure that the rates they give to colleagues within the team are really in accordance with the contribution of each member? Because we have some similar kind of course at our school here, and we had the problem with this objectivity of scoring.
Yeah, so what I do, they don't mark themselves by normal marks, but each team member has 100 points to distribute to other members. So they can distribute as they want. So when they do that, then so it's anonymous. So others don't know, but it's not anonymous to me. So I know who gave what. Yeah. So this is. So I don't think it's probable. So they can be subjective there, but if you see that 6 members, gave consistently low number of points to one member, it's quite, clear. Now, if one of them gave to one of the member very low point, but others didn't, that does not affect the final mark that much. So it doesn't matter really. So it's, I think I didn't have problems. So students, when they complained, I had few complaints, and then you just go into their attendance and you see that, they lost like 70% of team activity sessions. So I told them, well, your group got 70%, for example, a score. And of that 70%, you're getting 40 or 50%, which is quite good if you attended only 20 or 30% of the sessions. So it's we have this record of attendance, so I can really check, whether someone that was punished in the group, and you can see that, whether that person, and in 100%, that person is someone that was not coming, just did not, do anything in teams.
Okay, thank you.
Yeah, the problem we would probably encounter here is that in many situations, team members would explicitly or implicitly agree and split all the points evenly, so everybody will get the same number of points. But other strategies, I guess, can be implemented like here.
Yes, I had, so when you see, there are different, different kind of dynamics, but I don't know whether it's mentality that is different or what, but I don't think that they're that good friends in year 1 to, really share their marks like, without any problem. They would really need to know each other very well.
Yeah, okay. The crucial thing is also that you are the one who is allocating team members.
Exactly.
They are
so they're not friends, no.
Yeah.
They're not friends, and they are, it's a first year, so maybe that also helps because they don't know each other very well yet. So I don't think, a team member that was coming there each time, appearing on Wednesday at 9 o'clock, each time, and did solve questions and was engaged, would like to share that with friend who was sleeping at that time. I don't think it works that way now. Mm-hmm. They're quite careful about that. So if they split evenly, that's also all right, because it's maybe it can reflect the group, the team that worked well. So my impression is that what they actually that they actually score by their attendance and by their engagement rather than their knowledge, really. So, and that's all right, I think. So if that is the process of learning, it's fine. So in the overall, I have 60% is exam of this overall mark. So 60% is exam, 20% is what they did in these individual tests, and 20% is this mark, this score which they gain as a team. So you see, it's not, even if they punished, if one or two members of team, you know, gave a little bit less point to one, it will not really, you know, matter in overall. I don't think so.
So the exam is, I lost it a little bit. The exam that they do as a final exam is individual or team exam?
It's individual. It's individual, and it counts for 60% of the overall score of the mark for it. Yeah.
Okay.
And then there are 20% for individual tests. So 80% of the whole module is completely individual, right? And only 20% is what it accounts of these team exercises. So it does not influence a lot. But, you know, my experience is also, if you lower this a lot less, you know, if you put this to be 5%, I did first year, it was very, very low contribute, then they are not motivated to do it.
What is the overall reaction of students? Do they like this type of learning, or they prefer some other types of learning?
So I think I have usually good feedback. Overall feedback is good because they do this. We have this feedback from students for each module. So my module is usually, you know, quite high there in year one. And now the feedback that I get, I think they're just people that will never like this kind of, you know, active learning because it's quite uncomfortable. Because they, you know, if you have just there and you're lecturing in 100 people, they just think that, you know, they're invisible. So they come there, as you know, I mean, they come there, they're on Facebook or something, sleeping, daydreaming, whatever, you know, it's just not, you know, it's not possible to have their attention for 50 minutes. So the opposite, I think, for some of them, it's intimidating because they have to come, they come into teams and they need to discuss, you know, things. So it's a bit more difficult. And some of them, you know, are giving this feedback like, teach us, you're not teaching us. You're just, you know, making us work. You're not teaching us. So yes, I get that as well. But I think there is a, you know, a part of students which are just, you know, into that mentality of having, you know, lecture and sleeping there and then preparing only for exams. So there is this portion of students. So, well, it's how it is. But generally speaking, they like, they enjoy. And I think what is important, you know, they realize only at the end, actually, when they do these exercises and they actually are prepared for exam, rather than waiting then, you know, a few days before exams and then doing all together on their own. And it can be, you know, good feedback for them to know how much they don't know actually. So they can plan how much they have to solve. So feedback is rather good, but there is a portion of students which absolutely hates it.
Okay, yeah, we had also complaints from students in peer reviews that why should they do a teacher's job? They said it's job of a teacher to assess knowledge. Okay, we have questions from our online audience. One question is, do you give additional instructions how to solve problems, or do you value more creativity of students?
I think, yeah, it depends. So in this year one module, I think you need to instruct them a lot. And especially because we are general engineering, so it's a little bit specific. As I said, I have from 200 students, there are probably 30, 40 students, chemical engineers. So others might not have chemistry. It's a different system in the UK. So they could there could be like 50% of all students that didn't have chemistry for the last 2 years. So it has to be quite basic. You have to bring them all together. So I would say I instruct them somehow, but when I give them a question to solve, then it's on their own. They have to solve it. But it depends probably on a context, and it depends, you know, if I would apply this in year 4, that would be quite different. I would expect them to be more creative and, you know, be more able to create actually something out of the problem.
Okay, we have also one other question, which is very important, and this is how much synergy do you actually perceive when you observe them working in teams? Do you really, you know, on average, do you see that they really start to get the grasp of teamwork and start to using the synergy and utilizing all the benefits?
That's quite interesting, actually, point, because it depends on a team. So I would say, you know, a certain percentage of a team, you see that everyone is doing on their own, and, you know, they just compare results or something. And then there are, you know, a good percentage also students which are, you know, actually turn their table around and then, you know, talk with each other all the time. So there, I can observe both of them, and it just depends on the group, of dynamic, or psychology of the group or something. So what I try to do is to remind them. So each time I project a problem, I say, okay, now the next problem is this. Don't forget, we shouldn't select anything before, you know, you are sure that all members, so please do discuss. Or, you know, if they're quite somehow quiet, I ask them, you're quiet, are you ready to submit your answers? And then I say, no, well, I don't see you, you know, I don't hear you discussing. So I kind of try to repeat that point, you know, over and over about, you know, importance to be. But you're right, they're just, it's something that is psychology of the group, which I don't understand. So some groups just work perfectly with, you know, strangers, and some just don't. It just depends, you know, if you have a leader who manages to bring them together or not. So it really depends of people. But yes, there is an issue there as well. And then you might have, you know, people that are socially not very, very good with other people. So that can also be a problematic.
Do you give them any training or any reading material on how to work in teams?
Before no, I don't. But I think that's actually absolutely excellent idea. Yes, I do say, I do say things, but I remind them, but not specifically. What I was maybe from this discussion with all of you, maybe so what I would need is some kind of like activity to break that, you know, that timid situation, especially in the very beginning of how it's going to work. So yeah, something like that would be very, very valuable, but I don't know how to do that.
Yeah, we all face this problem. Any questions here? Yeah.
Do you think that this type of learning is more applicable in social sciences or something like that? On the one diagram, you introduced those bar charts about computer science and electrical engineering being less used, less using this type of approach in learning. Can you comment,
No,
please?
I don't think, you know, the engineering is quite complex. You know, problems that we have to solve will be quite complex when they go into industry. So they will need to work together with other engineers, other practices. And, you know, we have at university here, at the department, actually, we have a industrial advisory board. So these are people, so a group of people from different industries which come here and meet with the members of staff 3 times per year. And, you know, and so the role of that advisory is actually to, advisory committee is actually to, you know, from industry people to tell us what industry needs. And what they really say over and over and over and over are those soft skills. I mean, we can, you know, laugh, and we as an engineers, we say, oh, come on, don't learn me, you know, how to present things and how to talk with people. But actually, it's what industry really, really needs. What they told us, you know, if a student comes from a good university and has, you know, a first class, we are absolutely sure. So they tick the box of, you know, knowledge and, you know, problem solving skills. That's fine for us. What we are looking next, it's just someone that is capable to work in team, someone that can work in a, you know, a different environment, someone that knows to present, someone that will go in front of investors and, you know, present problems, someone to talk with people and resolve in the group. Someone, so they don't need individuals who are in the corner, you know, doing calculations on their own. That is not working. So I just think, you know, engineering is a very traditional discipline, while I think health sciences are, you know, people that understood that in those soft skills are really, really very important from very beginning. And if you see, even for problem-based learning, which is now quite spread in engineering profession as well. So still it was, you know, it was health professionals who brought it first. It was them who did this, you know, this frontier. And we as an engineers, you know, we like hammers, we like those traditional traditional things. And it's at least what I experienced here from college, you know. So just people like to do as they did 50 years ago. So I don't think it's you know, more or less applicable to social sciences. I don't think so. No, it's even, I think I would love to experiment this for maths, for example, would be absolutely phenomenal, I think.
Okay, since we have no further questions, I would like to thank Vesna, and I hope we will hear each other on some other topics as well in the future.
I think there is someone writing now.
Yeah, but we answered the questions. The person.
Okay, sorry. Okay.
Thank you.
So, yeah, you're welcome. So that's it, right?
Yes, that's it. Thank you, Vesna.
Thank you. Bye-bye. Thank you for inviting me. Bye.